Hello, today we are going to solve these two integrals, and let's start with the first one. So we can see here that we can divide our integral into three parts. 3 x squared dx, because we have a sum here, and we know if we have an integral of f and g dx, it will be equal to sum of integrals of f and g dx. Yes? So here we can see that the second integral will be 2x dx, and the third integral will be 1 divided by x dx. Then we can move our constant in front of our integrals and rewrite our integrals like this: 3 integral of x squared dx plus 2 integral of x dx plus, here we can't do such things, so write it the same. And now we can use the formula of integral of x to the power of n dx will be equal to x to the power of n plus 1 divided by n plus 1 plus c. Here and here we will use this formula, and here it's another case. Dx divided by x is equal to logarithm of x plus c. So here we can write 3 multiplied by x to the power of 2 plus 1 divided by 2 plus 1, then plus 2 multiplied by x to the power of 1 plus 1 divided by 1 plus 1. And here we can see that it is logarithm of x. And here, and here we need to add some constant, so we can write constant c, which is constant from here, here, and here. And that's all. Here will be x to the power of 3 divided by 3, and these numbers we can delete. And here will be 2 and 2. So as a result, we will have x to the power of 3 plus x to the power of 4 plus logarithm of x plus c. So that's our answer. And then let's move to the second integral. And here, first of all, we can see that our line in our numerator have power of power 2, so we need to write a square root of a to the power of 2 plus 2 multiplied by square root of a square root of x plus square root of x to the power of 2, and all of it will be divided to square root of a multiplied by x dx. And here we use formula a plus b to the power of 2, which is equal to a squared plus 2a multiplied by b plus b squared. So next we need to divide in this line into 3 parts, 3 integral. It will be equal to integral of a divided by a and x square root of and x dx plus 2 divided by, well, nothing, 1 dx plus integral of x divided by square root of a multiplied by x dx. And what else we can do? We can see that here we will have square root of a divided to square root of x dx plus 2 integrals dx plus integral of square root of x divided by square root of a dx. And a is some constant, and we can move it and write it here in front of integral square root of a multiplied by x to the power of minus 1 divided by 2 dx plus 2 integral dx plus 1 divided by square root of a. So we move our constant like this here. And here we have x to the power of 1 divided by 2 dx. And then we will use this formula again. And what we will see here, square root of a multiplied by x minus 1 divided by 2 plus 1 divided by minus 1 divided by 2 plus 1. And here will be 2 multiplied by, here we have x to the power of 0. So if we add to this 0, 1, we will have x to the power of 1. And here 1 divided by square root of a, x 1 divided by 2 plus 1 divided by 1 divided by 2 plus 1 plus constant from real numbers. And we can rewrite it a little bit more simpler. So here will be square root of a, and then minus 1 divided by 2 plus 1, it will be square root of x divided by minus 1 divided by 2. So we can actually write it, well, minus here, for example, and 2 here. Why minus? We have no minus. Minus 1 divided by 2 plus 1, it's 1 divided by 2, I'm sorry, plus 2x, and plus, let's see, here we'll have x multiplied by square root of x and divided by 1. Divided by 2 plus 1, it's equal to 3 divided by 2. So here goes 3 and 2 we can write here. And plus c, where c is constant from real numbers. So that's the answer to our second integral.